We talk about artificial intelligence as if it's weightless, a ghost in the machine, a network of code floating in an invisible cloud. But Anthropic's recent jump to a $30 billion revenue run rate signals a change in the product. They are selling digital labor hours produced in gigawatt-scale factories. Generating that volume of synthetic labor requires immense physical exertion. It takes thousands of tons of metal, millions of gallons of cooling water, and raw electricity running through massive industrial processors. Artificial intelligence has finally moved out of its ethereal software phase and directly into its heavy industrial phase. To see the scale of this mobilization, compare the projected $1 trillion AI infrastructure spend to the largest engineering projects in history. This private investment is larger than the inflation-adjusted costs of the Apollo program, the Manhattan Project, and the U.S. interstate highway system. This massive shift in capital means private funding now drives build-outs at a scale once requiring entire nation-states. In this landscape, the winner of the AI race will be the one who controls the most concrete, copper, and cooling systems. The first wall this boom hit was the hard limit of global semiconductor manufacturing. The demand for intelligence is outstripping the physical capacity of foundries like TSMC to print chips as fast as NVIDIA can design them. This bottleneck is driving the sovereign fab movement. Elon Musk is planning a terafab foundry in Austin, Texas, aiming for a capacity of 100,000 wafers per month to bypass external suppliers. Even with a supply of chips, there is a second, more difficult wall, the power grid. Gigawatt-scale data centers are overwhelming the U.S. grid. Right now, 2,200 gigawatts of new energy projects are trapped in interconnection queues. This gridlock forces tech giants to act as energy companies, signing multi-billion-dollar deals to restart dormant nuclear reactors. We can see this in Memphis, Tennessee. To meet demand, Anthropic, a software lab, was forced to lease the Colossus One supercomputer from Elon Musk, securing access to over 220,000 GPUs and 300 megawatts of power. The smartest models in the world are now at the mercy of the infrastructure barons who control the megawatts. Eventually, the expansion of AI will hit the thermal and geographical limits of the planet itself. This is the logic behind orbital AI compute, a plan by SpaceX and Anthropic to launch data centers into space, where they can harness unfiltered solar power and escape the political constraints of the terrestrial grid. But space introduces its own physics. Dissipating 1 gigawatt of heat in a vacuum requires over 1.2 million square meters of radiator panels. Because of thermal management and radiation, the heavy industrial phase of AI will remain earthbound for years. The scramble to leave the atmosphere shows how the scaling bottleneck has moved. The ceiling for intelligence is now determined by the capacity of the power grid. As the industry shifts, AI is consolidating into massive, sovereign infrastructure grids controlled by a handful of monopolies. A regulatory strategy focused purely on software weights faces a new physical reality. It is difficult to enforce terrestrial standards on a gigawatt-scale infrastructure that can operate as its own energy and compute island. Serving a subpoena to a satellite swarm or unplugging a sovereign, space-based data center would be a logistical impossibility. Political sovereignty is being absorbed by the power of the infrastructure itself. If governments cannot practically regulate these gigawatt-scale factories, how do you govern a trillion-dollar agentic economy? Governance requires moving the choke point from the physical factory to the identity of the digital laborers exiting it. Before an AI agent can access financial rails, its agent passport must be cryptographically verified through the DNS network. Anchoring this identity in the DNS provides a kill switch. If an agent violates its mandate, the network can instantly revoke its access to APIs and financial systems without needing to touch the data center. The competition for dominance has moved from the math inside the models to the physical power grid and the identity networks that connect machines.